Hello there. In this video we're going to look at a very clever application of synthetic division that is used to evaluate polynomials. So for example, let us assume we have the function f of x is equal to 3x to the power of 4 minus 2x cubed plus 5x squared minus 7x plus 4. And let us assume we want to evaluate this at a bunch of numbers. Of course, if you know order of operations and you know that you are capable of avoiding any possible arithmetic error or using a calculator, this might not be of interest to you. But this can be used in order to do, say, some mental calculations on this, or just to make it easier overall in order to evaluate polynomials. So let's start off by looking at a couple of evaluations that we should already be able to do by hand. So for example, if we want to evaluate f of 1, we pretty much just remove all of the x values to get just 3 minus 2 plus 5 minus 7 plus 4, which we should know to come out to just positive 3. If we were to plug in another number, say f of negative 2, so that's going to give us 3 times negative 2 to the power of 4, minus 2 times minus 2 to the power of 3, plus 5 times negative 2 to the power of 2, minus 7 times minus 2 plus 4. If you were to work out all the details of this, you should see that this comes out to 102. But it's possible, extremely, even for the most brilliant minds, that you might come up with an error due to some negative issues. Or maybe you might transcribe the problem wrong. So let's see how we can use synthetic division in order to evaluate these things. So let's start focusing on f of 1. So I'm going to begin by putting 1 outside of my synthetic division box, and I'm going to grab the coefficients of my polynomial of interest, which is going to be 3, minus 2, 5, minus 7, and 4. So I'm going to begin by bringing 3 down, so 3. So 1 times 3 is 3. 3 plus minus 2 is going to be 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. Negative 7 plus 6 is minus 1. 1 times minus 1 is minus 1, and 4 plus minus 1 is going to be 3. And imagine this is equal to f of 1. Pretty neat. So let's assume I want to find f of minus 2. So I'm going to begin by putting minus 2 outside of my box. Put my coefficients, 3 minus 2, 5 minus 7, and 4. So, begin. 3 comes down, so we have 3 times minus 2 is minus 6. Minus 6 plus minus 2 is minus 8. Minus 2 times minus 8 is positive 16, plus 5 is 21. 21 times minus 2 is going to be minus 42, and minus 42 plus minus 7 is minus 49. Minus 49 times minus 2 is going to be positive 98, and 98 plus 4 is going to be 102. And as we should already know, this is f of minus 2. So, both of these approaches do have their level of computations, but at least I believe that this is a little bit more straightforward in terms of computations. So let's do one more example to sort of illustrate this. So example 3. So let us suppose that f of x is equal to 3x to the power of 7 minus 4x to the 5th plus 2x cubed minus 5x squared plus 1. So what we're going to do is we're going to find f of minus 3 using synthetic division. Notice here that this is a degree 7 polynomial. So even if you were to use synthetic division, it's possible that this number is going to be extremely large. All right, so also notice we're missing some powers. We're missing 6. So we're missing 6, we're missing 4, we're also missing 1. So let's make sure we're not missing anything. So we have our degree 7, 6, 5, 4, 3, 2, 1, 0 coefficients. So let's make a nicer box. So our coefficient for 7 is going to be 3. Coefficient for 6 is 0, coefficient of 5 is negative 4, coefficient of 4 is 0, coefficient of 3 is 2, coefficient of 2 is minus 5, coefficient of 1 is 0, and coefficient of 0 is 1. So we're looking for f of minus 3, so minus 3 is going to go outside of our box. Alright, so let's make our synthetic box a little bit more neater. So our claim is that this answer in this yellow box will be the answer that we are looking for. Alright, so let's begin. So 3 comes down. So 3 times minus 3 is going to be minus 9, plus 0 is going to be minus 9. Negative 9 times negative 3 is going to be positive 27, and 27 minus 4 is going to give us 23. 23 times minus 3 is going to give us minus 69. Added to 0 doesn't really add anything at all. Minus 69 times 3, so now our numbers start to become big. So that's going to be 207 plus 2 is 209. 209 times 3 is going to be something a little bit higher than 600, in particular minus 627, plus negative 5 is going to be negative 632. Negative 632 times 3 goes into the 4 digits, namely 1896, plus 0 is 1896, and then 1896 times negative 3 is going to give us negative 5688. Add 1 to that, that's going to give us negative 5687. And you can use a calculator to verify that this is actually what it comes out to. So I hope you enjoyed this extra little application of synthetic division such that it can be used in terms of evaluating polynomials. But of course, there is one application that is extremely important, and that is the following. So if f of a is equal to 0 for some polynomial a, then this implies that x minus a is a factor of f. So this is why every time we were trying to show that this was a factor of some polynomial with some coefficients an minus 1, an minus 2, down to, say, a0, we were always choosing the opposite of the number to go outside because we were actually evaluating it. And once we evaluated it and we got a remainder of 0 here, that means this was our polynomial quotient, which implies that x minus a is a factor. So if this was, say, g of x, for example, then that means f of x factors into x minus a times g of x. So this is synthetic division and its applications to the evaluation of polynomials, and also how it can be used to factor. Hope you enjoyed.